Hi, my name is Calley. I am a high school math teacher at the American International School of Chennai, and this is my Course 5 final project. I love using technology in the classroom. Usually this technology takes the form of some kind of an exploration or an interactive activity that students can use to explore an idea in mathematics or connect more deeply to the formula. Here's a really good example from NCTM, Illuminations, where students could explore the properties of conics. And here's another example using Desmos online software that lets students consider the properties of a midpoint quadrilateral. And of course, my students often use Google Drive to collaborate on activities, such as this PowerPoint, in which every student contributed whatever they could find about conic sections to share with the group. Digital activities are always engaging for students. They allow students to visualize what's happening with the mathematics, and they let them explore on their own and learn their ideas in an inquiry-based manner. However, through COETAIL, I've been learning a lot about connectivism and how my students might benefit from actually being connected to other students through their math studies. So the challenge to me is, as an IB Mathematics SL teacher, with a lot of pressure from the outside with course deadlines and exams, how am I going to make time for my students to connect to other students and reap the benefits of that kind of a connection? Furthermore, I wondered how I could incorporate some of my other goals for student learning into a unit that would connect my students to other students. It was important for me to keep my standards in mind as we move forward, because my students have high expectations for themselves for their exam scores, and so do parents, and so does administration. And of course, it's important to me that my students are successful on these exams. How can I put it all together to make sure that what we are learning in the connectivism unit is meaningful as well to their regular math instruction? Well, I am a big advocate of the Common Core standards for mathematical practices. Now, whatever we think about standardized testing or the Common Core hubbub that's going on in the US, there isn't much discussion about whether or not the mathematical practices are meaningful. These are the habits of mind that mathematicians use when they go about the process of creating new mathematics and thinking quantitatively in general. The standards for mathematical practice that I wanted to focus on for this unit were, first of all, to reason and critique the reasoning of others, and also to attend to precision. I decided on the following unit plan. Students would start by examining an IB Pass problem and its mark scheme. We'd look for ways that the syllabus topic had been blended together. Then they'd take some time writing a problem. They'd write up their mark schemes. They'd make a video of themselves solving the problem, just like some of the review videos that we had seen online. I would share everyone's problems online and add a Google form so that they could receive feedback from students around the world. I even found some teachers to collaborate with. This plan sounded great. I wanted some backup, so I talked to one of my colleagues. In our math department, we've been working hard on understanding the value of the math practices. Our department head, Calley, has been teaching the IB for a long time, and she knows a lot about the practice standards. I asked Calley, why is it important for students to critique others' work?
What is important to one person may not be important to another. So this kind of the sharing of what they feel is important. For some, precision is important. For some, reasoning is important. So when they critique, they say, "Oh, this is important. You haven't mentioned that, and it would be good to have that." So they each learn from the other. Criticism really helps them improve. And when they learn it from their peers, they are more amenable to listening and making corrections rather than learn it from a teacher. All right.
I also asked Calley's opinion about students writing an IB problem instead of just doing one.
What is more difficult, writing a problem or doing a problem? Writing a problem, of course. And this is because when you solve a problem, you're going through a set of routine procedures. But when you write a problem, you have to clearly define the problem. You have to be very clear about what you want from the problem. Your language should be appropriate. So you should be able to get across the meaning of the problem and what you want them to do in a very simple and clear language. They also make sure that the assumptions they have made are they reasonable assumptions or not. So we have to pay attention to those. Yeah. And Einstein once said, I can take 55 minutes to make a problem, but 5 minutes to solve it.
Right.
So I think it's absolutely.
With all of Calley's advice in mind, it's time to get to work. Students got out their calculators and looked at some past problems and started creating new problems and mark schemes. Let's talk to some of the students about what the kind of problems they're making and what they're learning.
So this problem is solving derivatives using the chain rule. And so first we have to solve the problem and find the derivative. Then we have to find the minimum by equating it to 0 and then solving it, and the answer is 1. And then for the next one we have to look at the two graphs and find the intersection point using the derivative, and yeah.
So what kind of problem do you think you can write that uses the same curricular ideas? Do you have any ideas yet?
I was thinking using something that has the same idea of using the chain rule, and I like how they use the lnx, but I don't think I can use that for the other problem. Like maybe I'll use trig functions or something like that.
Okay.
This problem is about probability, and it connects a lot of topics in probability, for example, combined events, and at the end it gets to binomial distribution. And in my problem, I tried to integrate the calculus by adding the distance travel part. Yeah,
So was the original problem hard to do?
it was okay.
Okay. Are you making yours much harder?
I'll try.
Well, we got the first problem that I did in class. We used it was just this basically. It was just a circle, and it asked for the radius and stuff like that. But then
Okay, so you can see from the students' engagement that the project was going really well. But unfortunately, a lot of things really didn't go my way for this COETAIL project. For one thing, I was sick, and I missed 4 days during the time that I was supposed to be implementing this unit. It was already a really tight fit because it took me a long time to finish the previous unit, which was on solids of revolution and calculus. So we ended up not having enough time. That being said, my students and I still created a cool resource. It's just that not many of them got to finish their videos, and the videos that we did make, we did in such a rush that they weren't of very high quality. So I'm going to show you what the site looks like that we created, and we can have a good look and think about what this project could have been like if it had been totally successful. So this is the website that I created with my students. It's called Rate My Math Problem, AIS Chennai. First of all, in theory, this would be an interactive IB Math self-study session for students, and I did add a disclaimer. These problems are written by students, and so they're not perfect. It's a good exercise in critiquing the problems as you work them. If a student wants to choose a particular type of problem, they can click on a blog post title, which gives you a pretty good indication of the problem itself. And they can also click on something in the cloud to see what are the most common topics, or they could search by syllabus topic. All are available. I also added on the side here a little form to send to me for teachers or students interested in joining the collaboration. Let's take a look at the probability problem that's shown here. The student created a good-looking problem. It looks a lot like an IB problem. It is using the syllabus topic of conditional probability, and it's typeset nicely and looks very professional. So as we look through here, it seems very appropriate, and so hopefully a student would go and work the problem and then check out the mark scheme. Here you have the mark scheme that again looks very professional, but as we start going through, we can see that one of the probabilities, the probability of boys given 3 in the bus, is 9.7. So a probability of 9.7 is about a 967% probability. Uh-oh, that's an error. The great thing was that lots of people found the error, and then they were able to give some feedback on the error. So the feedback form links to a Google form. And I'd like to know, first of all, if you're giving me feedback, are you an SL student or teacher? Are you just another student or teacher? Or are you an alien life form come to take over the planet? How helpful did you find this problem? How correct did you find this mark scheme? And how interesting or unique was the problem? And we would like some additional feedback. The form is submitted and the form is shared then with myself and also with the student so that we both can get some feedback about the quality of our problem. In general, I think that this website could be really useful. Unfortunately, we just didn't have the time to share it out to other teachers before they had to get really into their review for the IB exams. So, what can I say? It didn't turn out perfect, but I learned a lot from this project. I learned that it takes a lot of time for students to incorporate technology if they don't already have the skills. I learned that the end of the second year of the IB program is not the right time to try to incorporate that time into a big project. If I think about the SAMR model, I think that I definitely substituted writing a problem digitally with writing a problem by hand. We augmented it, however, by making it available to more students. The activity was significantly modified by the audience, and I think there's potential for the activity to really be a full redefinition if we could turn it into a resource that was available to many students. And I learned that I think that I could create a really cool resource for my students to make meaningful end-of-unit assessments and to share them with others to get feedback. Thanks, COETAIL. I learned a lot.